Alright, so welcome to part 2 of this video. We are building a simple OLED screen management, basically, or control using Fairness state machine and using a simple switch case method. So previously we wrote this code. If you have not watched that part, just look for the part 1 of this video where we set up and explain what you are going to be doing. And so in this one, we are going to complete that part, and I'll try to explain as much as I can as I go on. So I've not done this before, and like I've not done it in a long time, but I'm just looking to refresh this kind of say control system. So most of the things I've not figured them out, but if some part goes wrong or it's not very accurate, feel free to correct me. And yeah, so let me just increase the font size of this thing. And next thing we do, previously we defined this button number of button presses check here. Remember, we are using a single button to control the screen, and our goal is, as we press the button, the push button, we cycle through these states. These are just 3 states, a very simple, very few number of states. Anyway, so I'll start by controlling, rather writing the software or the part of code for this button press. We have a template for that, which was this static unit button read. But if you look at this closely, this is it's not production level. So one of the major problems you face with such push buttons is what you call the debounce, right? Debounce. So I'll just briefly explain what debounce is, if you know it better. But debounce is basically when you are pressing a button and you have, let's say this is a timing diagram, the button is, let's say, pulled high, then you press it. Instead of it going low for some amount of time and then going high when you release it, what actually happens is that you press it like that. It's high. Use a different pen color here. So it's high. You press it, but here there are several high frequency noises, or rather noise, and then you release, and that happens. So the bouncing is removing this high frequency noise at this point, right? So you can do that in hardware or in software. So I'll do it in software at the moment. It's cheaper and I think faster for me that way. You can do both. Anyway, so to debounce, what you are going to define is a number of variables here that will help us track the button presses. So the first thing that I will do, let me draw. The first thing that I will do is define the timing variables. So if you look closely, this is T for time. So there's a length here that we want to track, right? There's a length of time we want to track here, and just ignore it completely. So I'm gonna define an unsigned long of a debounce interval of, let's say, 50 milliseconds. 50, this is in milliseconds. Then I need to keep track of something called the previous button press, right? And then I'll keep track of current press this time. So current press time is equal to 0, right? Press time. Okay, then this is 0. Now next is we have to check the button state. So I'll have a unit ht button state, right? And then I'll have another variable called the int 8t last button press, last button state. All right, so initially, I mean, the circuit diagram has pulled this pin high, the button pin high. The button state can start as high or low, doesn't matter, but for us to debounce it, let me just remove this. So the first thing we do is check if the, the first thing we do obviously is to sample the pin. So we say button state is equal to digital read. It was called the menu button pin. So once we read that, we wanna check now if there's a change. If the current state is not equal to the previous one, which is the last one, right? Which means that the current one is reading low. Remember, the last one was high, so it means that we have pressed it, so it's low at this point. It's let me just draw right here. It means that if we have this see colors, mid-rate, so it means it was high. So if there's a change, we are here at the we are right here. Okay. So if there's a change, that means we need to say now the last, we need to update the last button state is equal to current, is equal to button state, sorry, button state. Okay, let's go to button state. And now the next thing we do is action. What action are we carrying out if there's a change? We can increment the count, we can turn on LED or what, but what I'm gonna do is just check now if button state is low, right? If button state is low, we do something, we debug ln button button what released. Actually this should be high, because you release the you press, it goes low, right? This becomes true, you update it, and now if you sample it again and see now it's high, it means you have released the button. Okay, now all of this should happen after this time. So what I'm gonna do is say if current press time, so what's the current press time? Is the current milliseconds, millis, right? If current press time minus previous press time is greater than or equal to the debounce interval, then I can do all of this just like that. Okay, but we need to be updating the previous press time. The previous press time is updated every time there's a change in the pin level. Basically, if maybe we press, let's say we press it right here, let's say this is the noisy part, right? This is a noisy part. So anytime there's a change, it goes high, it has been released, there's a change, this becomes the previous press time. So what you're measuring is this length of time right here. This is what you're measuring, this length. Anytime there's a high, then a low, you update the previous time, you get this length. So if this length becomes more than or equal to 100 milliseconds, then you sample the pin again and see now, oh, it went high, and that button has been released. which means it has been pressed and released, which is a valid button press. Anyway, so we need to be updating that previous button press time on change. So we say previous, it's got prev press time. Press time is equal to current. Let's go to the millis. You can do that, or you can use current millis. You can use current press time. Sorry. Okay, so that's that. That's okay. All right. So remember, this code is not returning anything. So you can change this to static void. Then something else you need to change is the signature up here. So this is static void button read. I'm just monitoring the screen recorder here. So in the loop, let's call that function. We remove this because now it's not returning anything. Debug button press. We don't need to debug the button press at the moment. We don't need to do this. Let me just remove this part. Ignore the rest of the code, and yeah. So let me just comment this out. Let me comment it out a little. Comment it out. Then you just read the button and see what happens. So what you expect is to, when you press the button, you expect this to happen, to print button released. So I'm going to open the upload port here, then upload the code to ESP. So I have a breadboard here with I have a breadboard with the button connected. I don't know whether you can see this push button right here. I'll share the schematics. So to upload the code with PIO, you say PIO run -t upload. Press enter. Should compile that and show us whether you have any errors or any warnings for that code. So it's compiling. It's gonna take maybe a few seconds, but meanwhile we want, our end goal is once you press the button, we want it to increment the press count. We basically want to count the number of presses that we have had so that we can cycle through these states, right? So that we can cycle through these states. If you had several buttons, maybe for example a menu with, not a menu, like a keypad control with 4 buttons or 5 buttons, you wouldn't have to repurpose the press counts or the one button to do that job. Okay. All right. Right now it's linking, uploading. All right. Let's see. So successful. Let's open the serial monitor by the PIO device. You open it with PIO device monitor. You put the baud rate. Baud is 115/200. Let's see whether it prints anything. Right, let's reset the pin and press the button. Oops, nothing happens. What did I do wrong? Oh, I want to initialize the serial port. Serial dot begin. I'll put this function in its own function later on. Begin baud rate is baud rate. Yep. Okay. And then if I initialize the GPI unit, okay, that's initialized as the input. Okay, let me upload it again. So close that, upload that. And then as it uploads, so these are a simple sequence of events. Initialize the pin, GPIO pins you're going to be using, then initialize the SSD 1306 OLED. So I discovered my 0.91 inch OLED is not working. I think something is burnt. So right now I'm using the 0.96 inches OLED, but it should work the same. Open the serial monitor, waiting for download, reset that. Let's see. Right, so if I press and release, it does that. It just prints button released, button released, button released, and that's cool. So we have eliminated the debounce, and now we are ready to go with the rest of the code. Now I'm gonna just make this screen better. Open the Zen mode. Right, I think now it's more visible. Okay. All right, so let me close this. Close this. Yep, this thing is bloated a little bit. Anyway, so I want to keep track of the button presses. So there's a point I was counting the press counts right here. Right, press counts. So the action, instead of debugging button released, I'm just gonna increment the press count. Right, the press count. Now we have confirmed that this is gonna work. So in the loop, we can debug btn press. Let me comment. Say btn press count. Okay. Debug ln. Then here we can say debug. Then you can use a logger for this. I'll create another video for building an event logger for embedded. So I'm gonna call these presses, and let's see how that goes. Close this. I mean, you don't have to be uploading it all the time if you know what you're doing, but just let's test as we go. Okay. Cool. So open the device monitor. Presses are 0, press 1, press 2. So if you look at the bottom here, you can see when I press, it increments, and good. So we are able to cycle through all the button presses. Cool. Now, what happens now if we press the buttons? So right down here, I'll comment this code we wrote in the last video. If the button presses count is 0, the current state is gonna be home, right? So what we can do is debug ln debug what? Let's say current state debug ln what? Current state. All right, now this current state will be returned in terms of numbers. So what I like to do is write a simple helper function to help me return the states as a string. You can have an array of characters for that. So up here, I'm gonna say a char pointer state in string form. So these are 2 by 2 matrix. So I'm gonna say how many states do I have? Is 1, 2, 3, 4 states. 4 states by maximum number of characters per state is this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 plus null termination 11. 11 equals. So I'm gonna say the first one is home. The second is menu. I'm just gonna copy these guys here. Menu option 1. The third is menu option 2. The fourth is menu opt3. opt3. All right. Yep, like that. Okay, so we have that. So anytime the state is 0 or is home, I'm gonna print this instead of printing 1. So down here in the loop, the current state is going to screen that. So here I'll print state string, right? Then current state, which means that let's see, what is this? How does it arguments of that type? Anyway, wait a minute. I can just create four. This is 1 2 3 4 1 2 3 4. Okay, so let's see. We want to print that as strings. So current state it starts at the 0, but the state starts at 1. So that's a problem right there. This is 1. Okay, so what I can do is put this as 0 so that it just references is the first character, first string, right? So let's see, let's make this 4. Okay, 4 and just an array of strings. All right, so let's see what that gives us. If you press the button, the presses 0, you expect to print home. Okay, so upload that. Okay, we have warnings obviously for ISO, the ISO standard that prevents string constant to that. I don't want to use strings anyway, so we'll fix the error, not the error, the warning later. So let's debug that. Reset this thing. So you can see the current state is home. If I press, should go to menu option 1. If I press, go to menu option 2. If I press menu option 3, let me remove. We have already confirmed the number of button presses. So close this. Just quickly upload. Just want to make the serial monitor faster, cleaner. You can change the upload speed if it's too slow in the PIO INI file. Right, so you see the state is home. I press the button, it goes to menu option 1, menu option 2, menu option 3, goes home again because I'm looping back to 0 here. Right, so 1 2 3 home, 1 2 3 home, 1 2 3 home. Cool, that's fine. Right, now let's do something with these states. Basically, we define the handlers. So what happens when the state is home? What happens when the state is menu option 1? What happens when the state is menu option 3, and so on. All right, so we said that if the state is home, we show the home screen on the OLED screen. So if I go to this function, you can see there's nothing there, right? So this is this function is supposed to show the home screen. Now, if you remember very well, in the last video we said that I'm just gonna cycle through Where is it? Where is my browser? Right, let me open the image that you are creating. The image you are creating right here. It was the OLED screen and pixel electric 0.96 to 0.91 inch. Yeah, this is the image you are creating. So if you look closely, we have these icons. We have this network, message, battery. So we want to create this. Now, if I come back to my sketchpad here, let me just remove all of this. We are done with these parts. We are done with this. Done with this. All right. Now, what I want to do is I have just ignore the bad sketch, but this is 64 pixels high. This is 128. All right. So my screen has two colors. The screen I'm using has two colors. There's, I think I have not measured, but the last time I did was around 15 to 16 pixels. Let's say 16 pixels. Right here, this is yellow, and then this is different. Is around 64 minus 16 is around 30 or 40, 48, right? So this is 48. So I want all my icons to fit right here. So I want a network icon. Let's use a Wi-Fi icon here. And then what was the other one? Home, not home, the battery. So let's put the battery right about battery. Let's put the battery right about here. Right. Then what else can we put? Maybe a message icon. There's only too much information you can put, but that's it. So we want this to hold a specific length, this one to hold a specific length, and this one to hold a specific length, other pixel size. All right, pixel size. So there's a tool to do this. There's a tool to do this. To do this sizing of the bitmaps. And what I'm gonna do is, first of all, from the Adafruit OLED library. So always follow the examples of other works that have been done before to expedite your work. So I'm going to open these examples 164 to see. All right. So the first thing that we always do is clear the display. Right. Clear the display, and then clear the display and then draw it. Okay, I'm trying to remember the name of that tool that was used to draw the bitmaps, but I mean I'll remember along the way. Anyway, so back to code, what we say is display dot clear display, right? Then we say display dot set cursor. Now this should be, I mean, if you're interested in the front end part of it, be my guest, but if you want to be very particular, you can always be measuring what number of pixels do you want from this point to the start of your image, right? Now I'm gonna give it an allowance of around 2 pixels, and then the top, This drawing is dirty, but yeah. Then this part 2 pixels, which means my cursor is going to start at 2 and 2, right? So let's look for that function. Set cursor, it's called set cursor. So set cursor, this is x, y. X is, remember in computer graphics, y is counted down once and x is counted from left to right. Right, so this is 2, then this is 2 at some point here. So back to code, you're gonna say 2 and 2, 2 and 2. Then let's just print some line here to say home screen. Home screen. I won't add the bitmaps at this point because there's a tool to do that, and it'll make my work way easier. Way easier. Print home screen, and then remember we used to say we said that after setting this, we call the display function display.display for this particular driver. Show home should work. So one last thing you should do, if we look at the examples here, is set the cursor size. I think text size, if I'm not wrong. Draw character, yeah, set text sizes. One is normal, 1 by 1 pixel size. Draw character, is it? Where did it go? Set pixel size. What's that? Set pixel size. Oh, set text size. Okay, cool. Yeah, it is. Set text size and set the color to white. So I'll just copy that and bring it over here like that. All right, so text size to 1, SSD white. Let me remove these comments. Cool. So I'm gonna copy this and then create other functions to handle. So static void show, what was the name of the, this is screen show menu 1, screen show menu 2, screen show menu 1, menu 2, menu 3. Okay, so go back to this right here, paste. I'm gonna copy this, paste that. You can create an API for this part and just be passing the message that you want to display. But for this case, I just want to show you how we cycle through the different states on the screen. Menu screen, no, menu option 1. Let's say menu option 1. Copy, paste it twice. So this is menu 3. 3, menu 2. Alright, cool. So all of these text will be displayed at the same point because you are setting the cursor at the same point. Okay, so in the loop, if the button is pressed once, we will call home, and down here it is using the switch case. This is now the FSM part, switch case FSM. Okay, state machine, just type it in full, state machine. Cool. So let's test it out. Upload. I hope there's no error yet. Upload, and let's see what you get. Upload. loading. All right, so let's open the serial monitor. Okay, so my screen is not responding for some reason. Okay, let's see. Display neat. Let's see. Let me check. So defines, let me check the address of that. The defines is okay. Main, where's the setup? Current state. Okay, let me check this function. Clear display, set cursor, print that. Setup. Let's check whether the screen was found. Else, debug, screen not found. So this also should be debug ln. Okay, F is for optimizing memory, but we'll do that later. So close this and re-upload the code again. Sometimes you might be writing code in like live demos and such things happen, and you debug it. There's no going back. You just debug and look for why your code is not running as it's supposed to run. So basically the screen is the one that is misbehaving. Let me see. Let's check whether it's being found first. Reset this. Reset and cancel. Reset and cancel. Scroll up. Cool. So screen not found. I think it's the address issue. Okay, let's see. Yeah, I remember that oops. Okay, so the address for a 128 by 64 changes. So they are saying 3D is for 128 by 64. Okay, let's check that. Let's change that and see. So find, no, it's in the defines. Screen address is 3D. Okay, oops. No, 3C and 64. This is another big mistake here. Height is 64, not 32. So I've tested with 3C and it has worked with 64 pixel height. So I hope it works this time around. Upload. Okay, so it was not found, and you check the address again. So reset, Control C. Screen not found. All right, I'm checking the I2C pins. Pin 22. Yeah. it's appearing as inverted here. So let's change this. This is the last thing that we do in this video. Then the next one, we create the bitmaps and the icons and more elegant menus. Upload device monitor, ready for download, reset, reset. Let's check. Oops, was not found again. Okay, let's debug that. Why is it not being found? Let's see. No, it's being found. The one who's writing the wrong thing. Screen found. What? Okay. I don't know where my head is. Yeah, so yeah, I think it's good. It's good. It's working super good. So in my callback functions, set text color to white. Let me just comment that out. Go back to my browser. Confirm that they do almost the same thing. Draw char. Yeah, so this is okay. Okay, so I'm going to upload it one last time and then we'll call it a day. Right, so it's uploading. Okay, so yep. This is testing the hardware itself. Yep, 3v3 is out. Okay. Open the device monitor. And yeah, you're good. So I'm not able to show you this on the camera, but it's changing, it's printing the states as expected. And I'll be able to show you that in the next video once we create the states, the bitmaps and the screen menu itself. Alright, so I hope you learned something in this one, and I'm gonna see you in the next one. Thank you and have a good one.